In this lesson, we're going to be learning about logical operators. Now, you might be wondering why we covered booleans in their own separate lesson. Reason being is because they play a really important part in the way logical operators work, and we're going to look at that in this lesson. So what are they? Logical operations include any operation that can manipulate a Boolean value, which is why we just talked about booleans. So what are the logical operators? So let's assume that variables a and b exist and each one of them holds a Boolean value. The value of a and b is described in the following table. So we have a in the first scenario to be true and we have b to be true. In order for the and logical operator to work, both a and b must be true. So if a is true and b is true, you're going to get true. If a is false and b is true, you're going to get false. If they're both false, you're going to get false. And again, if a is true and b is false, you're also going to get false. Or is the next logical operator. So in order for this to return true, only one has to be true. A or b must be true. So if a is true and b is true, obviously that's going to return true. If a is false but b is true, it's going to return true. The only instance where or returns false is when both of the operands are false. So if you have a equals false and b equals false, it's going to return false. And again, if one is true and the other is false, it will return true. And the not operator inverses the value that it's called on. So if you have not a, you're going to get false if a is true. And if you have not a, where a equals false, it's going to return true. So let's look at some examples. So if we have true or true, so in this first case, since both of them are true, this is going to return true when this evaluates. However, we put not right before this, so whatever this evaluates, we're going to inverse. So we have true as returned from this, but we're inversing it so it produces false. So not true is false. So false or true. Well, the way or works, as long as one is true, it will return true. So the result of this expression is true. Now, an important thing to note is I went right for the parentheses. Python follows PEMDAS, just like you learned in math class. Parentheses always come first. So you evaluate the parentheses, and then you continue to evaluate the entire expression. So here's an example to determine whether or not a person can become president. So if you have a Boolean over 35 and a Boolean citizen. So someone can only become president if they're over 35 and they're a citizen. However, when this runs, since over 35 is false and citizen is false, this is going to return false. The person in question cannot become president. So they can be president if they're not an illegal citizen. So if a legal citizen is false and they can be president if they're not an illegal citizen, well, the inverse of false is true. So in this case, they can become president. Let's take a look at this in PyCharm. I'm going to go ahead and create a new file. New Python file. We'll call this lesson 7. So let's go ahead and create a variable called over 21. And we'll set this equal to false. And let's create another variable called DD, or designated driver. And we'll set this equal to true. And we'll create another variable called can enter bar. And a user can only enter the bar if they are over 21 and they have a designated driver. So let's see what this evaluates to in this case. So let's go ahead and print can enter bar. So I will go ahead and run this. And you see that we get false because both of the operands, an operand is one of the two values involved in a logical expression. So over 21, since that is false, automatically this kind of short circuits and just will evaluate straight to false.